Hi everybody. In this video I'm just going to explain how the STR frame works. If you've already seen some of the pictures and posts, you'll know that STR stands for Simple Tilt Rotor, and that's again just due to the mechanism used to tilt the booms, essentially keeping it very simple. Just really, these are the parts used for that. So there's nothing complicated about it. That's kind of the goal with this, was to keep the design very simple, just to not add any overhead with, any kind of pulleys or belts or linkages that are just not easily available. So let me go into the frame itself. This version here is essentially the production version. Here's real quick what the prototype looks like right now. You can see it's running square booms, which are wooden booms. And I did intend for the production version to run with those. But if you want a cleaner, more refined look, here's a version with 12mm carbon fiber booms. With the round booms, you will get some more tilt on the booms. With the round ones, I'm getting maximum 45 forward and 20 back. 45 is a lot. Honestly, I don't run that much, if anything, for a couple seconds, and then I'll get off the elevator. I will go into the radio setup just so you can see how that is. It's very simple. I've done nothing, different here as far as setup. The only thing is you'll activate the accessories option to run the servo. You could also just run it off your traditional receiver if you don't, want to mess with the software side. So here's what the final version is looking like. It will fit the 12mm booms and square booms, wooden booms. The reason for these, I really like the idea that you can just go to your local hardware store and pick up some square dowels and have parts for your quad. You don't have to wait 5 days or whatever to order parts. You can see on the prototype I have the motors mounted right on the boom, but to make it easier for people, I will be using a motor mount with a 16x19 bolt pattern and 12x16 for the smaller 1800 size motors. They also will come with an option for a guard. I don't see many people really even using them, but if you want to use them, there's that option, and so they'll mount, something like that. Okay, so let me just go back to the frame. It will have a left and right side. You can see this is facing forward. This is the left. The servo will go in here, and on your right side you'll be able to access the control board port from here. This should fit. Right now I'm using the CC3D. The NAES 32 should also fit here fine. I haven't tested one, but form factor is the same. The port I've seen is centered on some of the earlier versions. I think some of the newer versions have it off to the side, but I don't think that's going to be a problem. The only other thing with the round booms versus the square is that these pieces will be a left and right, whereas the square version, it doesn't matter. Okay, let me show you the prototype just because it's built up and you can see how it works. Just a final note on the carbon fiber version. This one right now, all of this weight right now, just what you see is 170 grams. Trying to think now, remember. I think this is at 620 or 650 grams, running on a G10 frame. And this frame right now is a shorter one, only fits 4-inch, and it's about 12 to 15 grams heavier than the 5-inch propeller version, which is bigger in the carbon fiber. So this 4-inch version will get a little bit lighter once we make it out of carbon fiber. Okay, so here's the servo setup. You can see it just essentially tilts with the servo, of course, and I've put a lot of different holes here for testing, but I keep coming back to the same pattern where everything's symmetrical. One of the things you'll probably hear, I don't know if when you fly it, is I think there's some prop wash that is hitting the rear propeller. I don't know if you can see there, but it overlaps a little bit, but so far it doesn't seem to affect anything. I've been flying with the stock PID settings, no tuning whatsoever. So I'm going to build up the slightly bigger version and see if that maintains. The only thing I did as far as setup on the CC3D is activate the accessories to connect the servo. You can run your servo directly from a traditional receiver, but since I'm using satellite, I needed to go that route. I'll show you the radio setup, because it's not very difficult to do. It's just a couple mixes and you've got the ability to control the tilt with your elevator. What else do you want to know? Okay, let me show you the radio, how that's working. Okay, let me plug this in. Okay, so traditional quad, of course, elevator controls the helicopter pitching forward or backwards. With this, you can do that as well by, let me show you on the radio. Okay, this is just the monitor screen for the servo outputs. I don't know if you can see that or not, but you can see the elevator is moving. And if you employ a mix, like I just turned it on, to mix elevator to elevator, that voids out that control. So you can see now it doesn't move at all, even though I'm moving the elevator. Then I employ a second mix to mix the aux2 channel with the servo. So now you can hear the servos moving. And you can see on here the channel aux2 is moving. So when you're flying, you can switch from traditional, here elevators moving, by flipping both mixes. Now just the servo moves. I mean, theoretically you can fly with both, which I haven't done. Just would seem like it would be a little crazy. I don't know yet. We'll see how that all goes. But to do this, let me show you the two mixes. So you would do this on whatever radio you have. Just about every radio now should be able to do this. So I have mix 1. You see elevator to elevator mix. Rate is minus 100 minus 100. So that negates anything you do with the elevator. Then to mix, let me go back. To mix in the servo, I'm mixing elevator to aux 2 where my servo is connected. And you can see I've got 125 and 100. So as soon as I do that, my servo works. So you flip both of them. One cancels out the traditional control, and then the second one enables the servo. And that's all there is to the radio. Now, there's a lot of options you have. You could mix it in with just a 3-position switch, a knob or a slider. But I've found so far that this works the best just because you don't have your hands off the transmitter. Trying to fumble with switches and knobs, and you have very fine control over the pitch. So that's the deal with the radio. And that's about it. I mean, I'll go into more depth. I'm gonna probably be doing a build video for this larger version, and then flying this to see how it does as far as tuning or pitch values. But like I said, for the prototype so far, I haven't touched any of them, so that's kind of worked out well. And that's it. Let me know if you have questions. Thanks and goodbye.